Jimo Joshua. Please, sir, you really have a good profile, and it's quite an honor having you here with us.
Oh, thank you.
You
Thank you
can.
very much. Okay, good evening,
Thank you so much,
everybody.
sir.
Um, I'd like to appreciate the leadership of Nicesa, Comrade Chinedu, Comrade Swipe. Personally, thank you very much, and my friends here, thank you for coming around. And I believe we are all here to have a very great time together. All right. This is what I love to do, to share my knowledge with you guys. All right. So, like, wouldn't like to stress up more points after the introduction. All right. So, what I would just like to make one or two comments so that pick up from there.
You're welcome.
All right. Thank you very much. I'm a structural designer. As said, I'm a young fellow like you guys, so we can rub minds together, and I can also share with you my knowledge at this level. All right, and also I'm a YouTuber, and I'll be sharing my screen so that the things I'll be sharing to you in the next few minutes will be interactive. All right, so I'll be sharing my entire screen, and I believe you can see my screen now. All right, can you see my screen?
Okay, you can see your screen. Yeah, your screen is coming up now.
All right, so
Okay,
I
you can
so
see
I
it now.
Yes, we can see your screen right now.
all right, great. So I have over 80 videos on my channel so that you guys can always go there and learn one or two things on structural designs and engineering also all for free. All right, so and I'll be here for the next 3 days to share with you the little thing I know that that I can share with you so that you guys can get better too as touching structural designs and engineering. All right, so straight to the point, we have three different agendas in this meeting together, and the first of which is to make you aware and competent, if possible, on the issue of general arrangement, how to frame or come up with a general arrangement drawing. All right, and secondly will be to introduce you to the software product structure, which is a structural design software. Of course, is popular in use now, and it can actually help out in your design endeavor. All right, so I'll be here to introduce you to that, and also we're going to be taking a practical design project of which if you registered correctly and with your email address with the form that was produced by Nicesa or provided by Nicesa, I already shared with everybody a document, and the document contains the drawing that we'll be using as a typical project in this meeting. How many of us received the document, please? All right. So definitely nobody here received the document. Probably you don't check your mail often or something like that. I sent yesterday before the meeting, long before the meeting. All right. So everybody has the document. Okay. So or her, as the case may be. All right. So to go straight to what we have today, I'll be showing to you the drawing. That's what I want to work on. All right. The first thing we want to do today is to create a general arrangement drawing. How to create a general arrangement drawing. All right, for some people that are hearing this for the first time, because the goal of this meeting is not to assume that every one of us have an average knowledge of everything we want to discuss, but so that a person who is under average or probably a beginner in the civil engineering journey um, could also come around this meeting and get to understand what we are saying as the time goes by, so that we'll not be leaving anyone behind for the start. Understand? So we want to pick everybody from the scratch, then develop the knowledge from the basics. All right. And before I say anything, before I go forward or further, I would like to apologize on behalf of my sister yesterday. It was a lot of issues to bring up the meeting. We had network issues. All right. We do not take it for granted, and of course, it was something that was unavoidable. All right, it was network issue. All right, straight to the point. To produce a general arrangement drawing, you have to first understand what exactly is a general arrangement drawing. All right, so a general arrangement drawing is a drawing that shows location or position, sizes of sections, that shows the type and material of structural elements within the structural framework. All right, so I'll go again so that you can get me. I just defined what a general element drawing is. A general element drawing is also called a structural layout. All right, and it's a drawing that shows the location or position, the sizes of section, that shows the type of material, of structural elements within a framework. All right, so what makes the difference between a structural drawing or a general element drawing and other architectural layout? The architectural layout is actually revealing to you, giving you the details of architectural components or architectural framework. So they are more interested in what you can see as the final feature of your edifice. So you find in an architecture or architectural layout, as you can see now, this is an architectural layout. You can find, in fact, you can see a car there. You can see bed there in the bedroom. You can see chairs in the living room. You can see different kind of things, movable things or whatever it is in that place. But that's because it matters to them as the architects, because they are trying to paint to you what is being conceived in their heart. But when it comes to a structural layout, because for a structural engineer, what we conceive in our, or what the architect are conceived in his heart as pictorial, we bring it as the beginning of our own enterprise and not the end. Because for the architect, what picture he frames in his heart, he brings it as the final product. So that is what matters to him. But we pick what he calls the final product, we pick it from there, then we have to create our own final product. And to us, what matters to us is stability first, safety second, and economy third. All right, so we want to see that these things that the architect had conceived as the idea and they had come up with pictorial representation or whatever it is, we want to see how these things can come together to be stable, how it can come together yet safe, and while not beating too much on the economy. All right, so it means that the attention of a structural designer or a structural engineer is not first drawn to the edifice or how beautiful, or the elements, how the elements within are positioned and all of that. No, he is much more concerned on what material would be adopted or could be adopted to ensure the stability and the safety of the structure. What sizes of sections do I begin to adopt? All right, or what locations would I put certain sections that would actually meet for the um, good combination of all my um, enterprise. So he begins to look into, you discover that his concerns will be much more of the safety, stability, economy, rather than aesthetics, positioning, dimensions, and all of that. Is not more of that. So that draws the line between the structural layout and the architectural layout. All right. So, but this is not to say that there will be a downplay on the architecture. No, because the first rule of providing a general element drawing is to always honor and respect the architectural document, because the architectural document is what has been passed to you to work on, to carry out your own enterprise, to see that this architectural layout or architectural conception comes to reality. You understand? All right. So you don't work against the architecture. you work to achieving the architectural framework. All right, so it's tough to say that the architecture is the human body that you see, and the structural layout is the intestine and all the internal organs that keeps the body functioning. You understand? So that's it. So you don't knock off the body because the intestine is there, and you don't carry your intestines alone to class or to carry your intestine alone to office and keep your body because it doesn't matter. No, they all have to work together to make sense. And that's what I'm trying to show to you here. All right, that's the first rule of general joy. And the second rule is to identify or understand the architecture. All right, if you can still hear me, can I hear something? I seem to have a very quiet.
I can hear you
All right, thank
loud
you.
and
I
clear.
can hear you. I can hear you.
Thank you.
We can hear you. Yes, I can hear
All right,
you.
thank you. It's all right, thank you. All right, the second rule now is to understand the architecture because I've seen a lot of people trying to make a structural layout without taking time to understand what is in the mind of the architect rather. Because you can't just interpret something you were not there when they were conceiving, and you hope to interpret it correctly without studying. In fact, a structural engineer is being observed that the structural engineer has a higher IQ in capturing details. Why? Because every detail in your structural framework matters and they have consequences. Every detail. So you want to understand what, how, why, where of the whole architecture, the idea. You are trying to look what's happening here. Why is this position like this? Where is the entry point? What are the levels in the structure? How are we moving around this place? Where are my elements allowed to stay, and where are they not allowed to stay? Because in the long run, your attempts to produce stability into the structure would not be an excuse for you to do something that will violate the rule or the code of construction. What do I mean by that? One of the rules that you need to keep at heart when you are preparing the structural element drawing is that not any one of your structural elements should violate the space of the architect. Like I said, you have to honor his drawing. For example, look to this architecture, the one you can see, this ground floor plan. If you guys can quickly run through your email, you see your mailbox. You see that I forwarded this particular drawing to you yesterday, far before the class. All right. So looking to this architecture now, you find that we have several spaces here, and we have living room where I'm hovering. All right, so in the case where you want to support this living room above this floor, or the slab above this floor, because if you check this drawing well, and which I said is number one of the things where you have to do is to understand what the building is like. All right, so after you have understood what the building is like, of course we are coming back there. You want to support this floor right here, and what you thought in your heart is to put a column right in in the middle of this living room. You'll be making sense to yourself, but you'll be very foolish to others because you don't want to support a thing and yet creating another problem. How do you want to create a column in the middle of the living room and say you want to support that slab? No, there had to be alternative means, yet wise enough. All right, so that's on that. So let's just go to understand the architecture. The architect would have provided for you several documents or several drawings in his document, of which one of those drawings would be the elevations, and the elevation is kind of giving you an overall pictorial view of what he intends or what he has in mind. All right, so checking through the elevations for the four sides, you should be able to come to a conclusion of what the building is like. All right. In fact, the first thing that comes to your mind when you check the architecture, the elevation, would be that you'll be able to capture how many floors do you have in the project. All right. You'll be able to know, okay, that this is the area of the project. the size of the project, you'll be able to know that. By the time you use the floor plans, you'll be able to know the entrance, the entry point. You'll be able to know the rooms, the number of the rooms, and the dimensions or sizes. You'll be able to know where the exit is. All right, so let's just take a journey to do that in 2 minutes so that we'll be able to do something meaningful on general mentoring. All right, so from this ground floor, by observation, you see that the entrance is right on this point where I'm hovering, right? So we have two entrances, or two entrance rather. I'm sorry. So we have one that links the carport to the lobby between the living room and the carport. All right, and we have another that comes from the main entrance to the ante room. You see that now? So you are trying to understand what's going on there. So we have two. So from there, it gets to the living room. And if you do not want to get to the living room, you can make another exit straight to the terrace on the left. You see that? Then from the living room, we can also enter into the master bedroom, which is right on the right of that side. Or we can keep going straight as my cursor is going. All right. Then on the left, you get to the bedroom, which has its own bathroom and toilet, right? Okay, so you can also keep going to get to the kitchen, and there are two entrances to the kitchen. One is before the lobby, and one is right after the lobby. All right, so if you escape the kitchen doors, you find another entrance that leads to the stairs. All right, so using the stair, you get to the first floor. But mind you, by the time you are out of the lobby or the second entrance of the kitchen, you are already outside. You are not inside the building anymore. You see, you are outside the building. So you have to understand that too. So you are using the stairs, you get to the first floor. And the first floor here, you can see already it leads to a lobby. And from the lobby, you can access the first bedroom on your left because you are just coming in. All right. Then on your right, you can access your bedroom and the two
Hello,
bedrooms.
hello.
Um,
Sorry for interrupting. Your screen is not much showing. Your screen is not much showing.
is that true for everybody?
No, no, it's showing here.
Your screen is showing. It's showing
I
clearly.
can view the screen from here. The screen is clear.
All right. Thank you very much.
Yes.
It's not showing.
Not showing. All right.
I can see the screen. I can see the screen.
Le- Probably I'll just share again. What about now?
It's still showing. It's still showing.
Okay. Let me just. Yes. What about now, everybody?
It's showing.
Yes, it's showing.
It's showing.
Confirm, showing.
Okay.
This
Now
is better
confirmed.
now.
Confirmed. Okay. Good. All right. So I've just taken you through my building, but you understand a thing. On this first floor that we are, you discover that there is a roof on the first floor. It means that you have to begin to ask yourself, what's going on there? For you to have a roof on the first floor, so you have to come back to your architecture, check your elevation, and see what's happening. So this is what's happening. So on this first floor, there is a lower roof. So right on the master bedroom, there is a roof. Right on the master bedroom, there's a roof. You see that right on this master bedroom here, there is a roof. So you understand that. And that's going to affect some of your considerations while making your general. All right, so let's just begin to do that. I gave you the master room, honor your architecture. Secondly, do not foul or do not foul the spaces, that is, do not go against the spaces of the architect. All right. And as we go further, I'll give you more rules. Okay, but to start with, this is how we'll begin to walk through. To create your first floor structural layout, you are using your ground floor architectural layout. All right, I'll go again. To produce the first floor structural layout, we use the ground floor architectural layout. How many people got that? And it's not confusing.
No, it's not confusing.
Oh, yeah, great. So it is to say that the reason for that is very simple, because our structural layouts that are going to is going to represent the position, the sizes of all our structural elements, and these structural elements most times they lie on the floor that is under them. All right. So if the floor that is under them is not considered in making the layout, you can be creating something of something bad. Okay, so the first thing I want to do is to just begin with my ground floor. Just pay attention. If you seem not to get anything, just let me know. All right. So check this out. This is my ground floor architecture. And this is how we want to do it. The first thing you want to do is to block this drawing so that you'll be able to write on this drawing without creating a mess. I can delete this drawing when I'm done, so that I'll be left with whatever it is I've drawn on it. I want to sketch on this drawing so that by the time I'm done sketching, I can separate my sketch from this architecture. That's the reason for blocking. So blocking it will make it a single drawing, and I can delete it, I can separate it at will. All right. So to block, when you enter control, when you enter B or right block, you have an option. Then you select block. You can name it anything. I can name it ground floor. Name it any. You can name it after your name. You can name it bright or something. Okay. So that's cool. You can see that it becomes a single drawing. So what I want to do now is to establish my grid lines, because grid lines are reference lines. By the time I begin to put into this drawing my elements without grid lines, I can't make reference to them when I'm working further instance. All right, and I was speaking with some of my students last week, I think, or this week, and I told them the importance of grid lines. You don't want to mess around with your project, particularly when you're having a large or bulky project without grid lines. You would be lost in your drawing and it won't make sense after all. All right, so if you want to know more about grid lines, you can check my channel as I've shared with you. I have something you should know on grid lines. In fact, you should always see on that page. There are a lot of things for you to learn there. All right, so let's bring in grid lines since we have already made grid lines. So I've started already now, so I can make reference. All right, so I want to begin to position my structural component. So, but I would like to start with my columns. So I will start by using a 225 by 225 column. I want to use a 225 by 225 column. Now, there is something we call engineering judgment, and also we have something we call preliminary sizing. I thought we'll be able to use a whiteboard tonight because I'm a structural designer. Yeah, I like to teach people from the first principle so that you know the reason, the why of things, and you not just be a one-way person. All right, I would have shown you something about preliminary sizing, but I can still explain. Now, engineering judgment is the ability to pick up the right decisions at the right places, necessary decisions at necessary places. Because, for example, how do I how do I just pick up the fact that I'm supposed to use a 225 column here and I use probably 450 by 25 column elsewhere or something. Those are engineering judgments, and engineering judgments are developed over time as a function of experience, as a function of knowledge. All right, and that's why most of us that have been to school will understand some basics about structural design, and it will make a clear difference between you that have been to the classroom and someone who had not been to the classroom. The decisions you guys will make will be different because you're able to judge as per what you're being taught along the line. But he had not been taught that. He doesn't have that knowledge. So that's one of those things that bring in engineering judgment. Over time, with experience and with use, you can also go about making right engineering judgment. All right. So for preliminary sizing, we do that in picking the initial section, the initial sizes for our elements or components before our final design. So our final design will finally suggest to us if our initial design or our initial guess is actually correct or working. All right, great. I really hope somebody's getting. Okay. So I'm starting to put all my column positions now, and it is not wise for you to just make a mess of your project by putting columns everywhere. No, that's not it. You put column at the right places, at the right place. Usually, your columns should not be too close and not be too far. In some places where you can do without having columns, please do without it, especially if you do not have consequences around that area. All right, consequences, I mean, if the span is not excessive and you do not have too many point loads at positions in between two columns. If you have too many point loads coming together in between two columns, I can create more effects as per load and moment effects on the column. So you want to position rightly to avoid those things. All right, so I'll continue. Someone in this class might say he would want one here, and it would not be wrong. Another person will say want one here, and will not be wrong. For me, there are two things because I'm thinking about what's going to happen to this part. Am I going to make it a cantilever all through at the first floor? So I need to check on the first floor what's happening to this part of my building before I would assume that these two columns here will be suitable for me like this. Then I make this beam cantilever. So I have to check my first floor, and that's how you begin to compare things together. So at that point, I really don't have a problem because that's the point where we have the roof above that floor. So it's not really, really all right. So I can just keep my column like this, knowing what to do when I come to the beam. I'll show you what to do when we come to the beam. All right. So on the left side of my drawing, I think I need a grid line somewhere around there. Yes. All right. So I have a column here, but because of this, I can take advantage of this circular column and remove this. Then I'll make this column on grid line 5 instead. I'll shift this column down to grid line 5 instead. I'll take advantage of this circular column. So we can have a circular column. All right. So you want to, as much as you are considering safety, you are considering economy, right? All together. That's how we do it.
Please, your screen is not showing.
I can't see anything from the screen.
You can't see anything, Abby.
Yes.
Yes.
For
I
you,
can see you. I can see my own.
why is it that some people can see and some can't see?
I don't know. We can't say anything. No.
You can just double tap on
Can
it.
you please make your
share the screen and let it be bolder than what you have now. Share it and minimize the attendees. Minimize the attendee screen and make your screen larger than what it is now, so that everybody can see it.
All right, I will do that. All right.
Now, this is better now. This is better.
Is it better now?
It's better, yeah. It's better now.
I can't still see anyways.
You can still see. All right, let me share it.
But I
Yes.
can speak from mine.
I don't think it's from my end. It could be network or something.
Yeah, let them end the call and come back in. It's not from your end. It's not from your end.
All right. Thank God it's not from my end. Let's continue. If you find a
If you're
difficulty,
not seeing the screen, maybe you should double tap. You should double tap on the this thing on the screen on that page. It will show.
all right, good. Thank you for that suggestion. All right. Let's continue. So there is something that we need to we need to confirm because I said we would have placed the column here, but for the fact that I have a circular column here, I want to see if I can span my beam between grid line 5 and grid line 7, which is about 5.775 meters. I know many of you have a background knowledge that a column to column distance should not be more than 3 meters. All right, that's background. But I tell you, the reason why you are a structural designer is not to assume or not to traditionally believe a thing without you using your design approaches to confirm those things. All right. So with this 5.775, I taught my private students how to design all these things manually so that they can be able to see if truly it will fail or it wouldn't fail, because that makes you a structural designer. You want to be sure while you are sleeping that what you have designed is yet going to stand. You see what I'm talking about? So with this 5.775, the only implication I'm seeing obviously in this thing is that this column at this point will be far heavier and might not be able to sustain it because of the span of there's going to be a point load at this point, a point load on this point, and this might not be able to stand. So that's the only thing that will make us consider a compromise on this whole span. And therefore, we're going to consider introducing one support in between in a way that is going to be concealed within the wall. I hope somebody is not.
Please, can you go over it again?
Okay, yes, I'll go back. I'll go back. All right, what I'm saying now is I said I thought of this while I was doing that I could have just had a column here at this point, but I saw just as the architect had wanted it, a circular column here. Instead of making this circular column just for aesthetics reason, I want to also take advantage of it as a structural component. So I want to span my column support between grid line 5 and grid line 7, such that I only have one support here and another support here. When I look at it obviously, I discover that there are certain weaknesses around this option that I have. And these are the weaknesses. I have about 5.775 meters apart from these two supports. All right. And which is not a problem because if I design it, it can always pass. But for the fact that this section is a 225 by 225 column, it will tend to place more load on that column and might not be able to support as much load as we have from that span, because the longer your span, it tends to develop more action on your moment or more value on your moment, transferring to that column. You see that? So this column might not have enough stuff to hold the moment or the beam connected to it. So we may need a larger section for this particular column. And for the fact that I will most likely have a beam coming here to form a point load on this span, and also a beam coming here to form a point load on this span. So it's going to be a lot on these two guys. And that's the reason why we're going to consider a compromise at this point by shifting this column. I'm not going to have this column here. I'm going to have it here. I'm going to have this column here. I'll take this one away from here and I'll conceal it right here, somewhere in between this. Who's getting my gist?
I'm getting it. I'm getting your gist.
So it makes more sense now. Makes more sense now. A total relief on this guy that was formerly here. So that's how we begin to juxtapose different options that you have within your framework. So, and the thing is that for general arrangement, for a drawing, rather an architectural drawing, several engineers can come up with several general arrangements, several perspectives, and all of them will still be right. It's just about approach. That's why I introduced this engineering judgment, because we judge things based on perspective, just things based on what we understand or what we believe to be true and workable. But all of us must arrive at a point where these things will totally work fine. All right, so I've solved these axes now. Let's move further to this and see what we have at that point. All right, so I can have also a circular column on this point, just as the architect wants it. There's nothing I can do to this one. That's what the architect wants. There's nothing you can do to it. And this also. There's really nothing you can do. Now, but this one, we have a weakness here. This guy doesn't have a beam connecting them together on the ground floor, because if you check the first the elevation, you see that there is no beam at this first floor level. There is no beam at the first floor level. So you don't have anything joining these guys together. How then do you want to support this? Okay, let's get back to it. How then do I want to support this wall or at this point? So it means I need to consider another thing here. This is what I would do as a designer. This is what I would do. I'll have a column at this point. And this column, from this point now, let me just show you a thing. If I plan to have a beam all through to this point, all right, let's see if this column has a beam that connects to all these walls, all these columns. If not, we might have to reconsider our first attempt. So you see that it's also open. It's also open. All our columns have no beam connection. So our GA needs review. It means what we said to be true here formally would not work, because this column has nothing to do in connection with your building. I mean, your other columns on the same floor. So what I'll do because of that effect now is to shift this back to position. Then we create another at this point. Since we don't have any help from this column, this column is standalone. This column is standalone to the roof. See that? It's standalone to the roof. So what we have now is going to be a beam coming from here down to this point. See?
No, no, no.
See that? A beam going all through like this. All through that way. Alright. So and we also have another that will come all through from this place down to this place. That's also another beam. You see what I'm talking about? Alright. So let's continue with our column and we'll come back to all this every time. We need a grid line on this so that I'll be able to span my column from this point up until this point. So this becomes my beam span now. You see that? Are you with me?
Yes. Yes,
Yes.
sir.
Yes, sir. Yes, sir.
Yeah.
I'm saying.
Yeah.
All right, great. Okay, so we'll have to find a way to support this also here, and I'll show you why I have to create another column behind this at this point. Okay, so we'll have another one here. Let's move. At this point, we have another one here. Now, when we are done, we begin to look into obvious columns. The columns we can actually do away with, and the ones we can keep. Because sometimes while you are doing these things, you might have positioned some things that you feel like not necessary, and some that are really necessary. But in the long run, you should not just mess up your building with too many columns because you want to support. Okay, let me have my three lines. Okay, so this span now, you discover that from this span to this span, when I have this column, is about 7.4 meters, 7.5 meters. Oh, that's way too much. So we can reduce that span since we have the advantage of walls down to see now. All right, so we have that. We have that already. Then we can move this from here. We have more. We can have a column here. See that? But this is a staircase region. There's a way we consider a staircase region. Um, Conventionally, you would hear some people say that it is always good to have columns at the corners of staircases. Well, I do not know the philosophy behind that because I hear that a lot. Except if you want to have beams at half landing, so that the columns can help you tie your beams at half landing. Except for that reason, I really do not see further reason for that. Okay, but for this scenario, let's see what we can make of this. This is 5.4 meters. All right, so we can try a thing out here. Let's try something different out. These two columns now, we can shift them to this point. Then we can do this. What I want to do. Then we enlarge them to become 450 in the direction, in this direction, direction. So there's it looks more rigid and it can go for that span. It looks more rigid and can go for that span. Okay. So let's check for more places where we need to attend to. Okay, this column exists in the architecture. So that's why you see that I can't select it because I was not the one that placed it there. So the architect helped me out with this intentionally, and I'm grateful for it because it's useful for me. So then I have to look for one other one at a corner here, at this corner. Now I have to look what's going on here. This is supposed to be a terrace or something, and there's no exit here. It could be a decoration. I do not. So for that reason, we just want to keep that one. Let's just keep it. So let's continue and fix a column here. Fix another one at this point. All right. Now because of this point now, you may want to do something. I would rather shift this one from this point. I rather shift it Yeah. Then I'll bring another one at this point. I'd rather do I'd rather do this. Some people would have done this because of their staircase principle. Would have done this also, so that this column and probably they want to create another column at this point because of the half landing reason and keep that. For me, it's not necessary. For me, is at this point it's too much. What are they supporting? So I'll gladly do away with these two guys. I'll gladly do away with the cost of reinforcement and the cost of concrete saved at that point. The client will be grateful for having this. All right. Let's just fix our beams. Now I want to be sure that we all understand the concept of primary and secondary beam. I had to make a video, but particularly on this primary and secondary beam. I think I have on my YouTube channel, because I discovered that people don't really understand, including site engineers. When they look in at a drawing, they can't tell which beam should come first and which beam comes next. And that is enough for a collapse, because a beam that is supposed to support another, if you put it before after rather, and you put the one that is to be supported as the one that should support, that will be a great disaster. So we have to understand the concept of primary and secondary. A primary beam is supposed to support a secondary beam. That is supposed to receive the other beam either as a point load or whatever it is. All right. So that is going to be needed here. Let's just keep positioning our beams rightly since we have the column already. So from here now, we have it down to this point. Offset. So I have a beam here already. I can also have a short beam over this place. Then when it comes to this master bedroom, I can cut it off. This is what I want to do. I can cut this guy off so that my beam doesn't cross that bedroom. Okay, so this can go way down to this point. This beam can go way down up to that point. All right. So I can have another beam over this point. We have, just pay attention. Now between this and this, I can cut away this, because this beam will be flying around my anti-room, and I want my anti-room to be flat. I don't want stuff like that. So I have to break that beam from there. Now at this point, I have a beam here already. So this forms a primary structure for me. Also, I could have a beam going through here. Then another one crosses. See that? Proceed. All still on the wall, no beam flying around. Now the reason why I had two columns here close to each other like this, because at this point there ought to be a connection, and definitely a column would help me connect these two beams together, being a corner. All right, so that's why I have that. Then at this point also I can have a beam run run through. Do not forget, this is a we are using a ground floor to do this first floor arrangement. So when we are done, we need to compare with what the first floor is exactly that I work with. Now at this part of the structure, I can have this go straight, and also another one as this. Now I don't need to put a beam on this wall. I don't need. So I can take this whole panel as a full panel. I can take this whole panel as a full panel. That's what I'm doing. All right. So and I have, yes, I have a beam here already. So no issues. I have a beam here already. No issue. All right. So we can also have a beam, a long beam, continuous beam, all through to this point. And I create an offset 2 to 5. Right. We have another that connects these two columns together, 2 to 5. So it breaks this panel and this panel. We have this panel also. All right. So if you had continued this beam to join like this, it will be showing within your bathroom, and it will really make sense. It won't make sense. So but this one can actually come through like this, and it's fine. Okay, let's pay attention to this part, and forge ahead. Just ahead. All right. So we have 2 to 5. This on this edge. Now I can copy down to this place to have such here. Now there are two things. There are two. But instead of me having here, I wouldn't have here. I may not have it. In fact, I'll decide not to have it there. I would rather have it here, but take it away, take away this part. I'll take away this part. See that? I'll take away this part. Then this part, I don't need to put anything here. I don't need to put anything. And also this part, I can have a beam. So I believe we have answered for the ground floor. Now, to be sure that all that you have done is making sense alongside all other drawings, you have to superimpose what you have done here on your first floor, so that you see how it fits into your first floor. If there are other things you need to add or remove, because most times there are other things you have to add or remove. So still the same thing, we have to block this one, then name it first floor. How people are still following me?
Yes, we are. Yes.
Okay,
Yes,
okay, great. So we have this already. I just need to copy what I've done without the architecture, and I'll superimpose on the first floor, which is meant to be my own business now because that's where I'm going. I just use the ground floor as a template. So let me put it on it and see if it violates anything. That is, if some column continue from the ground floor to the first floor, will it show in certain places? Will it go and burst out on in my bedroom? Will they be seen? Will it go and show suddenly in the toilet, or will it show suddenly in the living room? So those are the things we will need to check when we get to the first floor. All right, so let's start from here. So we see that it patterns around this place, but we need to be sure what's happening here. We need to be sure what's happening here. Is it not showing in the open? So let me get an architecture. So this is that part. Can you see? Look at where that column is showing. It means anybody coming from this bedroom to the walk-in closet would use his head to hit that column. I don't know whether you see what I'm saying. Let me show you. I'm talking about this. This column on the ground floor is inside a wall. This is that column. Where is that column now? This is that column. This is the column. But when it gets to first floor, if that column should continue, it means that if you are coming from the bedroom to the walk-in closet, probably want to change your dress or something, you would have to use your head to hit this guy because it's an obstruction. Did you get what I'm saying?
Yes, sir. Yes, sir.
So
Yes, we are with you.
so it means that this column has to stop on the first floor. It has to stop. So we have to terminate that column on that floor. Let me make it a little visible. We have to terminate this column, and that's why it's like that. I've stopped it. You see why you need to compare what you have done with what the floor represents. Let's go for another lookout and see if we are in trouble. All right. I hope we'll have another like that. Okay, so we don't have another like that. Well, we are lucky. So thank God we checked this. It could have been a problem, a very big one. All right. So meaning another thing you should note is that on the first floor, this guy is not a slab. It's going to be a roof void. So these are giving us the first floor general arrangement. So the only thing left for us to do now is to just clean it up, put dimensions, put our grid labels correctly. This is going to represent our first floor plan. And also, you are going to put the oh, I didn't put this one there. So we are going to put the sizes of our elements into all these things too. All right. So which is going to come out like this: 450 by. I told you what a general element means. It shows the sizes, locations, or positions of all these things. So and we are going to put our staircase and everything inside. All right. Because of time, we will not have enough time to do all of those dressing to make our things look perfect. But uh, I don't know. For many people that have been following me for since probably last year or 2 years, um, you'd notice that there was a time we had a course for general arrangement drawing on its own. Yes, we have a full course on general arrangement drawing on its own. If you
Esther.
like to,
Esther.
oh, is somebody speaking with me? Okay,
Sorry.
not me. All right. I thought the lady was speaking with me. All right. So we have a full course on general element drawing. If you feel that you need to make how to edit these things to look cool and some other things that you need as touching general element drawing, the course is very very cheap, very very cheap, and you can access it at any time. Um, word. So though you can just reach out after the whole timeout would suit you. All right, so what we just need now is to dress this and make it fine. We have done the major thing. Now for the ground floor GA, this is the first floor GA now. Okay, like I was saying, all your elements should come with sizes. You want to show that, oh, this is a 450 by 150, this is a 450 by 150, like that. Then you put all other things. You show that this is a first floor layout. Just right, first floor layout. So that's it. All right. So to do the ground floor layout, we have done the ground floor layout already because it fits perfectly to what we have, except for the fact that our ground layout, what you have there, because if you are considering a pad foundation or a pad and strip foundation, what you call your beams on this ground floor now will be walls, because walls are those things that would mean for the strip foundation, while the pad base for the columns. All right. So if you are considering a raft foundation, these beams will be literally beams. All right. But in this case now we are considering a pad foundation. So let me take away this general drawing. Now in this case, how do I now show it? I begin to put signs of walls there. Or if you don't want to use this, you can create arch to show that these guys are walls. All right. Now we can make all those dressings and everything in our own free time. This forms our ground floor layout. Now, what difference do we have when we get to the roof? We have, at this point, we have a small roof on the first floor here, but where we come, we are not done because we have to show that all these places at this point, they are slabs, 150 mm. This is a preliminary something. So you may want to put your direction for either one way or two way. Of course, I believe everyone should know what one way or two way is in this class. If you do not know, you may need to contact any of I do not know. I do not know. But hadn't been we had more time to interact, would have just done some preliminary software design business before time. Probably you would catch one way or two way designs. But let's see tomorrow we'll do some discussion along that line if possible. Yes, or you meet one of my private designs class students. Okay, so let's see what we have here. Let me just justify this. All right, so you can do this respectively if it fits the particular slab. Now this is a very large slab, and cool. So that's one of the things editing does. And like I told you in the video, in the GA course that I have, all these have been taught clearly. All right, for the roof GA now, what difference does it make? The difference that will be there is simple, which is that all these guys, this guy stops on the first floor. Let me copy this. I just want to show you something. You don't have to spend a lot of time doing that because we're ahead of time already. I just want to show you what to do to make it very fast. All right. Seeing that this first floor, the roof beams will be sitting on the walls of this first floor, right? So probably you will just want to pattern your beams to fit the walls on this first floor, right? So that you have the roof on it. So what we just do is to come here, copy this one, superimpose it on your first floor, you know that right on your first floor, this guy, this guy is not there anymore because now you have gone beyond this floor when you are dealing with the roof. You have gone beyond this floor. I hope somebody is agreeing with me that you have gone beyond this floor. So this guy doesn't exist. These guys don't exist. Now look at what I did now. Oh. Hello, are you with me? I want you
Yes,
to
we
see.
are.
I want you to see
Yes,
that
sir.
Yes, we are with
the
you. Yeah,
implication of
Well,
not blocking your drawing, because I just did that mistake now. The implication of not blocking your drawing. I can't separate my architecture from my structural drawing. I can't anymore because I didn't block it. Look at. There's no way I want to separate it again. Look at. So if you do that mistake, it's going to affect you. So I have to get back to what I've done previously. All right. So what do? I block this. I call it. Then I move it there. So as I was saying, I said, seeing that this floor, on this first floor, this part is the roof for the master bedroom. These two parts is the roof for the master bedroom, right on the first floor, according to what this architect told us here. So by the time we got to the roof for the whole building, this part will not be there. You won't find this part around there. You understand what I'm saying? Because this part is the roof. This guy you are seeing here is the roof on this floor. On this floor now, that's the roof. So when you get to this point here, there won't be roof for this guy. This guy's roof doesn't get to this point. That's what I'm saying. People don't still get me. Hello? Do I come again?
I understand what you're saying.
Thank you very much. I like that.
It's past the level of growth.
Yes. I think so. So at that point, what I'll just gladly do is to remove everything that has to do with that roof because it we don't have any business to do with it at that level. At that level. Sorry. I just have to clean it up. Same thing. So now we can let's remove the architecture and see if we have done. So you see now, at this point, this place doesn't have a roof. So we've cleaned that part off, even though we still need it. Let's just copy it. So it takes a lot of patience and thinking while you are producing a arrangement drawing because you are really thinking about a lot how to put this together to form something. All right. So all these guys now they are no longer slabs or stairs or whatever it is. They are now voids because these guys are roof beams. So and this is the sign we use for void. We are trying to show that there is nothing in this point but roof beams. So these beams now becomes rectangular section. All roof beams in this drawing now becomes a rectangular section. and not flange section. I hope you understand that. All right. So that happens all through. And you may want to create a beam here. You may want to extend. You want to extend this up here. So you are now come here. Then you have this one from here. It goes all through to this point. You see. So that happens all through for all your spaces. So to save time, you can just do that on the drawing that you have with you. But that's exactly what we have. All these guys are no longer slabs for us, rather they are voids. No staircase also, we have voids. So that's exactly this one becomes now our roof layout. What we are left to do is to clean up all the space to look as good as can. All right, so I believe we got all my explanations so clear tonight. All right, so because tomorrow is going to be an introduction to product structure where we are going to use this same drawing. We are going to begin to make an adventure into the design of this structure. So it's going to be an introductory part to the design process, and we have a nice background already now. So let's see if you have any question. Can we begin to raise them? Or
Yeah, I wanted to ask if you can get this file of this GA so that we can practice and also
all right.
compare.
I said it earlier that right long before yesterday's meeting, I shared this drawing everybody that registered on the 4th. Yes, I shared it to everybody. Check your mail if you have your mail. If you have your mail, sent
I
to
was trying to say the one with the GA, the one with this GA now,
okay
this
with the one
current
with this
one.
GA.
Yes.
Okay. Okay. I'll see. I'll share with you. I will send it to the mail to all the email I have on file.
Okay, thank you.
Welcome.
Okay, please, I wasn't able to register. So I don't know, and my email is not being submitted. So I don't know how I can get the files.
All right. President, please can you help me do something? If you can still help us get the registration link, can you help me share it
Yeah,
to the space so that everybody can
yes,
just
I'm
okay.
going to do that. I'm going to do that.
Yes, thank you very much. So that I can forward it to everybody on the space.
All right, sir. All right, sir.
Thank you.
I think we are at the end of the session tonight, right?
Thank you very yes, yes.
Yes, on the issue of the registration, please. Because hello, can you hear me?
Yes, I can.
Yes, on the issue of the registration, I have the link. I filled all the necessary columns. But there is this one that is requiring that I should provide my subscription fees or something, and I don't know how to get that.
Please can you chat the president after the time for me so that we can chat. All right. So any question as touching our class tonight?
Is there any other question?
I have a question.
All right,
Um,
try.
so when you are doing your GA, right? Is it okay for the beams to show in like some places like the passage or like the corridor, for the beams to show under the slab, or all the beams must be inside the walls too?
Now there are some spaces where unavoidably you can't have your beams directly on the wall, and everybody seeing your job will be able to relate and agree with you. excited to be at the lobby, and you just can't wait. Like you just can't leave your seat as it is. But in the places where it's closed, it's places where they won't take office visitors. So if it's at the lobby or at the front door, it's there, you will sit. But when you start flying to the bedroom or